recording again. Okay, so again, we keep going. Let me get this. Oh boy. Okay, wait, no. Darn it, come back here. Good. Good. All right. Okay. So again, we stop since the degree of the difference. Here, let me get the laser thing up. We stop since the degree of this difference is less than the degree of the divisor. Okay. So altogether, right, we have our quotient, right, which is the 3x minus 2. Our remainder is 11x plus 3. So from here, right, we have our Q and R. So we can write it out either way. So we have, this is our dividend. This is our f of x, right? That's equal to Q, 3x minus 2, times our divisor, d of x, plus our remainder. So I wrote it like that. Or if you want, you can write it this way. Either way. I mean, they're both equivalent to each other, so. Okay. What's nice about this is when you are dividing one polynomial by another, thanks to polynomial long division, you can always rewrite this as a polynomial plus another quotient, or another fraction, I guess so to say, where the numerator has degree less than the denominator. So, all right. Are there any questions about this? All right. Because I have other examples we can do. You know, because I know, again, I don't know if everyone has actually seen this before. I think in high school they teach this, but again, I want to assume that that I'm teaching it for the first time to people. So, yeah.
I'm a little confused with the first example that you went over. So I understand how you got at first the 9x cubed plus 15x squared, but how did you get the plus 3?
Where, you mean down here?
Yeah, so yeah, how did you?
Oh, because what I did was I took the 3x. Do you see how I got this?
Mm-hmm.
I multiplied it by this, the divisor, and that product is what we subtract. So 3x times 3x squared, that's 9x cubed. 3x times 5x, that's 15x squared. 3x minus 1 is minus 3x.
Oh, I see. And then you, okay. Okay.
Does that make sense?
All right, thank you.
Good. You're welcome. Good question. Are there any other questions? Again, I know this process is a little involved, so, but I thought this would be good instead of just teaching synthetic division. Synthetic division is a special case of this, but this is more fun, so at least I think so. All right. Let's do example 2. So now we're going to divide this polynomial by this polynomial. Okay? So now our dividend, right, is this thing. The divisor is this here. Okay? So just like before, we have this we're setting up, right? We have the divisor, d of x is out here, 3x minus 1. The dividend is in here. Okay? So what do? Well, again, we divide the leading term of the dividend by the leading term of the divisor. 6x squared over 3x. And again, when you divide these monomials, you divide coefficients. That's the new coefficient. For the variables, you subtract the exponents. So we get this, 2x. And again, the 2x, as I wrote here, you want it over its like term. Notice also, I forgot to say this, but the dividend, f of here, that's in standard form. There's no missing terms in between, right? Same thing with the divisor. That's in standard form, right? And there's no missing terms in between the term of the highest power of x. You know, the leading term, that is. So we have 2x. Now we multiply 2x with 3x minus 1, and we're going to subtract the difference. So, excuse me, subtract the product. So we have 2x times 3x minus 1. That's 6x squared minus 2x, and we subtract that. Now, when you subtract it, again, this is what I like to do. I like to distribute the negative and add. Okay, so that's what I'm doing here. 6x squared plus negative 6x squared, you get 0. Here we have 10x plus 2x, we get 12x. Okay, and this minus 5 thing we bring down, as you can see. Notice I brought it down. I brought the minus sign down as well. Not just the 5. Okay, now, do we stop? Well, you can probably see from here we don't, but why? The degree of this difference is the same as the degree of this, the divisor. We want it to be less than, or we want the difference to be 0. So we have to keep going. Let's do it again. So 12x minus 5, right? That's our new dividend. So we basically repeat the process with this taking the role of what was in here. So we have 12x divided by 3x, leading terms. And of course the x is canceled. 12 over 3 is 4. So we put plus 4 here, right? The 4 is over its like term. It's positive 4, so we put plus 4 here. Now the 4, we're going to multiply, over here. The 4 we multiply and then subtract that product. So we have 4 times 3x, that's 12x. 4 times minus 1 is minus 4. And we subtract the difference. And again, I change it to addition and I distribute the negative. I think here I forgot to put the addition sign, but hopefully you still understand what I did. So, here I remembered the addition sign. So we get 12x minus 12x plus negative 12x, that's 0. We have negative 5 plus 4, that's a negative 1. But now we stop. Okay, now why do we stop? Well, because the degree of a non-zero constant is 0. Which is less than the degree of this. So we stop. This is our quotient q of x. This is our remainder. And so by the division algorithm, we can write this. We have 6x squared plus 10x minus 5, right? That's equal to 2x plus 4 up here, times the divisor, 3x minus 1, minus 1. Minus 1 is the remainder. Okay? So I wrote it that way, the answer, that is. Okay? Unless really, you only have to do that if I ask you to. If you clearly indicate what the quotient and remainder are, that's really what I'm looking for. Okay. Are there any questions about that? Okay. All right, so let's stop here because we have like 10 seconds left. So again, with the exam, I'll do my best to get it by next week. Again, I know it's taken me a while. I'm really not happy about that, but I'm doing